The Operational Tracking and Aircraft Assignment modules of FASS, FMCU and FAMU include functions to monitor aircraft utilization and to plan maintenance checks. This consists of multiple parts. 1. Parameterization of utilization tracking, in particular the measures by which each check type is planned. 2. The tracking of actual and planned aircraft utilization, measured in block hours, landing cycles, and chronological time. 3. A hierarchy of maintenance check types. For example, a C check resets the utilization measures of all the check types beneath it, like B checks, weekly checks, and so on. 4. A simple tool for maintenance planning, namely rolling out a sequence of maintenance checks across a fleet using average daily aircraft utilization. 5. Insertion of maintenance checks based on actual utilization measures derived from completed flights and future assigned flights. The FAMU module merges seamlessly with the operational schedule by gluing the future schedule, either draft or corporate, to the end of the movement control window. It tracks live and expected block hours, cycles, and chronological elapsed time along the timeline. Down each aircraft, it accumulates 3 utilization measures for each check type, since the last effective date and time for the previous check. In places where the next check is not planned within the maximum allowed utilization specification, the required check is flagged with an expiry marker on the chart. The marker is a visual hint to the maintenance planner to add a suitable check prior to its appearance. When measuring utilization since a previous check, the system takes the maintenance hierarchy into account, whereby a superior check resets the utilization of a junior check. Depicted here is an A check resetting the utilization of a weekly check. The senior check need not have its maximum utilization measured using the same criteria as the junior check. From utilization tracking, we move on to maintenance planning. The legacy classical way that maintenance was planned is by generating maintenance sequences, in which a check type is rotated among the aircraft in a fleet according to average utilization statistics. For this purpose, the system offers the Add Maintenance Series function. In order for maintenance checks to be added using this function, there need to be gaps in the assigned flights to accommodate them. You can either set the time constraints to fit known gaps, or you can unassign suitable flights before starting. In this case, the schedule is already assigned, and there are convenient gaps into which to place the maintenance, so it is preferable not to destroy the pattern, but to rather use the gaps. Observe how the planned maintenance rotates down through the aircraft comprising the fleet. These planned checks can subsequently be locked to their aircraft. An assignment generator cannot 100% guarantee that the locks will be honored, but setting a lock makes the algorithms go to extreme lengths to keep them in place, at the expense of accommodating flights. It also causes problems to be raised in response to locks that have not been honored. After generating a maintenance series, there will exist maintenance expiries for check types that are not reset by the plan series, or where the checks of the plan series have not been scheduled in time. This can happen because there was no gap in which to plan a maintenance check inside the configured time slots, or because the schedule's actual utilization is greater than the average used in the series generation. These expiries can be fixed one by popping up the context menu on them and selecting the Fix Expiry function. Various rules govern how the expiry can be fixed. For example, how far backwards it is permitted to move to find a gap, and whether or not it is allowed to unassign flights. A better way to plan maintenance is to fix all the expiries in one shot. This function generates the maintenance checks down each aircraft at the points in time where they are actually needed, per the utilization of flights assigned to that aircraft. As each expiry is fixed, it resets the utilization measures of that check type and all its junior types. The next expiry occurs at exactly the flight which causes a utilization overrun. That expiry is then fixed in turn when the scan arrives at it. Using the Fix All Expiries function improves maintenance efficiency by reducing both overruns and underruns. Overruns are a legal problem and are only permitted in limited cases and must be compensated for in subsequent intervals. Underruns increase costs by reducing flying time and by doing redundant maintenance. In addition to planning maintenance by series or by fixing expiries, you can also add individual checks using the Add Maintenance function. Using a standard duration for the given check type, the system calculates the end date and time from your specified start. You can also lock the maintenance as discussed earlier and simultaneously remove downline maintenance checks of the same type, because they obviously will no longer be optimally placed once this one is scheduled. Note that you can assign a maintenance to a production line as well. This is a simple way of placing a constraint on the resources available to do maintenance work. It is optional, but when used, the maintenance line view reveals any overuse of resources that are available. Besides maintenance planning, the FASS Aircraft Maintenance Unit also provides the functions needed to manually update aircraft utilization statistics in case they have lapsed or in case of an ab initio take-on of a new aircraft. This includes setting the date of the last actual maintenance and/or the last effective maintenance of each check type. One of the important reasons for planning maintenance against an actual schedule is that flights do not conform to cyclic patterns despite arguments to the contrary. Extra flights are added for special functions and holidays. Flights are removed or downsized during periods of low demand. And flights are adjusted at the starts and ends of seasons to align with adjacent seasons. When you add those variations together, you find that utilization patterns change all the time. Ideally, they are